Witam serdecznie, Szanowni Państwo, dochodzi godzina 9, więc myślę, że spokojnie możemy zaczynać. I dziś właśnie będziemy dotykać tematu zaawansowanych polityk sieciowych i mikrosegmentacji jako zapobieganie rozprzestrzeniania się oprogramowania ransomware. Jest to dość wyjątkowe spotkanie, gdyż będziemy podchodzić do tematu od strony bardzo praktycznej. A co za tym idzie, ja spędzę z Państwem jedynie 10 minut, 9-10 minut w języku polskim, a następnie już do samego clou tematu przejdzie z Państwem pan Petr Linke, który jest CTO producenta Novicom. Obecnie już jest to nasze 5. spotkanie z tej serii i właśnie co miesiąc, poczynając od marca, mieliśmy możliwość rozmowy o Elizie, o Adnecie, BVS-ie, ostatnio również w czerwcu o połączeniu z zewnętrznym nadzorem bezpieczeństwa SOC, a dziś właśnie będziemy dotykać bardzo palącego, dotyczącego nas wszystkich tematu zapobiegania rozprzestrzenianiu się oprogramowania ransomware dzięki zastosowaniu naszego unikalnego produktu Adnet oraz zaawansowanych polityk sieciowych i mikrosegmentacji. Na sam początek jeszcze kilka słów na temat samego Novicomu, ponieważ myślę, że warte jest podkreślenia to, że jesteśmy czystym czeskim producentem, który specjalizuje się w rozwiązaniach sieciowych w zakresie zarządzania, monitorowania i zabezpieczania sieci. Orientujemy się głównie na średnich i dużych klientach, a przede wszystkim to, co nas wyróżnia na rynku, jest to, że wraz z naszymi partnerami staramy się promować na rynku dostęp do aktywnego nadzoru bezpieczeństwa SOC, co realizujemy poprzez nasze wyjątkowe portfolio produktów, czyli BVS, Elizę oraz dziś omawiany Adnet. Również warte wspomnienia jest to, że jesteśmy czystym producentem, jak przed chwilą mówiłam, czyli nie realizujemy bezpośrednio sprzedaży. Sprzedaż dla nas realizuje i wraz z nami nasza autoryzowana sieć partnerska, która jest obecna w Czechach, ale również za granicą, a w tym oczywiście również w Polsce. Na poprzednich spotkaniach dość szeroko mówiliśmy o naszym aktywnym koncepcie cyberbezpieczeństwa, o aktywnym SOC oraz tym, jak właśnie wygląda nasz wkład w tą koncepcję oraz co jesteśmy w stanie zaproponować naszym klientom w tym aspekcie. A idąc po kolei i bardzo krótko, jest to wizualizacja sieci, jest to cały obszar zintegrowanego zarządzania usługami sieciowymi, następnie gromadzenie, analizowanie, korelowanie logów. Mówiliśmy również o tym, jak ciężko jest zabezpieczyć nasze organizacje in-house. Dlatego również tutaj wychodziliśmy z takim optymalnym, funkcjonalnym modelem dla organizacji, który łączy w sobie połączenie, kombinację obszarów in-house, outsourcowanych jako model optymalny, funkcjonalny, który jesteśmy w stanie dość szybko wprowadzić, zaimplementować do organizacji i który przynosi naprawdę znaczne oszczędności rzędu 50–70% na technologii, na wsparciu i na wykwalifikowanym zespole. I tutaj już idąc bardzo w skrócie oraz idąc właśnie po kolei, jeśli chodzi o nasze rozwiązania, BVS jest to pełna widoczność zasobów i ich komunikacji przy wsparciu decyzji, przy rozwiązywaniu incydentu. Dalej Eliza, czyli gromadzenie, ewaluacja logów i na końcu cały obszar zintegrowanego zarządzania siecią, a wraz z tym również wsparcie dla monitorowania i zarządzania w sieciach dużych i rozproszonych. I tutaj właśnie przechodzimy już do samego Adnetu, gdzie będę miała poświęconych kilka slajdów na temat tego rozwiązania, jakim jest wyjątkowa integracja DDI i NAC. DDI, czyli DNS, DHCP oraz IPEM, czyli integracji zarządzania adresacją IP wraz z podstawowymi usługami sieciowymi i co stanowi o wyjątkowości naszego rozwiązania z kontrolą dostępu do sieci NAC, co pozwala nam na podwyższenie efektywnego zarządzania przestrzenią adresacji IP, a przy tym również i zarządzania bezpieczeństwem dostępu do sieci w sieciach dużych i rozproszonych. I właśnie idąc już dalej, jeśli chodzi o AVDNet jako operacyjne narzędzie sferze bezpieczeństwa jest on już dziś gotowy na potrzeby zaawansowanego modelu bezpieczeństwa, gdyż totalnie upraszcza potrzeby związane z zarządzaniem IP i wprowadza porządek w sieci. A przy tym również pozwala na pełne zbieranie informacji z różnych źródeł w modelu sieci scentralizowanej, ale co również istotne, rozproszonej. I tutaj właśnie mamy z operacji DDI-NAC, z bardzo silnego L2 monitoringu, również o przepływach w zdalnych lokalizacjach z NetFlow, IPFix, a przede wszystkim o logach dzięki możliwości zbierania syslogów w zdalnych lokalizacjach. I wszystko to stanowi środowisko dla operatora SOC, który dzięki takiemu narzędziu jak ELIZA jest w stanie zorientować się, czy pojawiło nam się w sieci jakieś zagrożenie. Następnie we współpracy z BVS, z narzędziem BVS, które służy do sprawdzenia wpływu sprzętu na usługi biznesowe, jesteśmy w stanie podjąć odpowiednią decyzję oraz wyprowadzić reakcję na incydent. I tutaj właśnie w momencie, kiedy musimy zapewnić natychmiastową reakcję na zidentyfikowane zagrożenie, pojawia nam się adnet. Stanowi o unikalności adnetu, to są właśnie jego funkcjonalności. Z jednej strony sfera bezpieczeństwa, z drugiej strony sfera administracji, zintegrowane ze sobą. Jeśli chodzi o dzisiejsze spotkanie, to będziemy właśnie dotykać tej sfery bezpieczeństwa, czyli będziemy mówić o NAC-u, o zaawansowanych zasadach sieciowych, o zaawansowanych politykach sieciowych i o mikrosegmentacji. Jednak nie jest to wszystko. Jeśli chodzi o tak kompleksowy produkt, jakim jest Adnet, mówimy też o zintegrowanym DDI-u, o możliwościach integracji z zaawansowanymi systemami wykrywania z różnego rodzaju SIEM-ami, z możliwością zbioru informacji z różnych źródeł, z mocnego L2 monitoringu, ze switchy, z ich kopii, a wszystko to stanowi właśnie środowisko dla operatora SOC i służy do budowy aktywnego SOC-u. I również już tu jeszcze kilka słów, zanim przejdziemy do prezentacji, do samego clou praktycznego produktu, kilka słów o Adnecie jako o NAC-u, jako o urządzeniu NAC, które obsługuje właśnie pełne 802.1x jako kontrolę dostępu do sieci przez radius standard, a także i jego uwierzytelnianie i autoryzację przez dynamiczną kontrolę VLAN, a również NAC jako kontrolę dostępu do sieci na podstawie MAC-ów. Jeśli chodzi właśnie o uwierzytelnianie MAC, to jest to u nas dodatkowe zabezpieczenie. I właśnie tu opowie później Państwu właśnie Pan Petr o trzech metodach, jakie posiadamy do wykrywania spoofingu MAC, co jest dość bardzo interesujące. I dalej, jeśli chodzi o sam NAC z uwierzytelnieniem MAC z ochroną, mamy tu bardzo wydajną segmentację sieci, czyli mamy zlokalizowane określone urządzenie, które alokujemy do określonego WLAN-a i tam już możemy zastosować określone polityki globalne, dalej izolację sieci WLAN i tak dalej, i tak dalej. To, o czym mówią również nasi partnerzy, to jest korzystna dwufazowa implementacja, gdzie zaczynamy od fazy pierwszej, nakładamy DDI, czyli wprowadzamy uwierzytelnianie MAC z zabezpieczeniem i dalej idziemy już w drugą fazę, gdzie stopniowo podnosimy ochronę w postaci wdrożenia pełnego 802.1x wraz z zaawansowanymi politykami sieciowymi. I co jest właśnie tutaj dość interesujące, to jest to, że Adnet rozwiązuje niedokończone implementacje NAC w standardzie 802.1x, z czym nie każdy nasz konkurent sobie radzi, gdyż posiada ograniczone wsparcie dla suplikantów. I dalej ostatni slajd już o zaawansowanych możliwościach, jakie daje izolacja urządzeń w określonej sieci WLAN, która jest oparta na dynamicznej kontroli ACL, DACL. I właśnie tutaj polityki pozwalają nam na zastosowanie polityk w ten sposób, żeby urządzenia nie widziały się w jednej sieci WLAN, co jest bardzo korzystne, jeśli chodzi o zapobieganie niebezpieczeństwu rozprzestrzeniania się ransomware'a. Poza tym nasz zaawansowany NAC pozwala na uproszczenie, na transparentność polityk bezpieczeństwa, gdyż Gdy ustawimy już polityki globalne, wtedy nie mamy potrzeby tworzenia polityk według lokalizacji. I to wraz z połączeniem z Trusted Pools, czyli automatycznym zarządzaniem zaufanymi urządzeniami w zdalnych lokalizacjach oraz z unikalną kombinacją DHCP i NAC, tworzy nam naprawdę interesujące i mocne rozwiązanie. I właśnie w tym momencie ja bym chciała już przekazać prezentację dalej. Będziemy kontynuować w języku angielskim. So now it's the time that we are getting to the clue of the presentation, and when Petr Linke will hand over the presentation. Petrze, I hope that you are already ready.
So, at the first, a little bit already to introduce. If we talk about advanced network policies, we must first look at what network model can be encountered. In the past, the sites were simple, and very often all the devices were in one network, so-called flat network. So you can see it here on this picture. This means that PCs, servers, printers, and so on could communicate with each other without any restriction. In the contrast, a segmented network is divided into individual networks, e.g. network for PCs, network for printers, network for servers, and so on. A frequently used model is that the security policies on the segmented network are implemented on layer 3 network device. In practice, it looks that we have some access switches. In large networks, the access switches is connected together through aggregation switches, and then is connected to layer 3 networking device. For example, firewall or layer 3 switch. The security policy itself is then implemented on the layer 3 network device. This means typically that it's possible set the rules for communication between individual networks, but communication in the same network is not restricted. The exception, of course, is if we have network devices supporting port isolation, then it would be possible to restrict communication in the same network, in the same VLAN. However, port isolation is expensive and places high demands on the central network device. With this site model, we often find that the individual VLANs that separate each network corresponds to the network and location. AG VLAN number corresponds to the third octet of the IP address of the network. Then the own policies on the layer 3 network device is defined on layer 3, layer 4 and above. And if we have more locations, there is separate security policy for each location because there are different networks and VLANs in each location. To sum it up, it means that security policies corresponds to the third layer and are tied to their locations. Typically, communication on the same network is mostly not solved. In contrast, it is possible to build a site model with global VLANs across sites. AG, we have, for example, VLAN 10 for users, VLAN 20 for printers, VLAN 30 for IT services, and so on. And on these VLANs are binded, the networks correspond to their locations. This brings the possibility to implement policies on layer 3 network device based on the second layer from this VLAN to this VLAN, for example, from PC VLAN to server VLAN, and 4 and higher layer, this protocol, this port under these conditions. So when we explain on the picture, the same, we have here access switches, binded together through aggregation switches, and connect to layer 3 networking device. On the access switches can be applied dynamically assigned security policies, and on the layer 3 networking device is global policy. Why the policy is global? Because if we use global VLANs, in this case, we set the policy from this VLAN to this VLAN. This is layer 2. There is no information about layer 3. And this protocol, this port under these conditions, this is layer 4 and upper. And if there is no, on the global policy, if there is no information about IP address of the network, it's mean that the policy is the same for each location, because the location is the same, only with a different, typically with different networks. So typically in this case, the VLANs corresponds the global security domains. It's mean from PC domain, where is connected the PC devices, to server domain, where is typically connected the servers, which provides the IT services, or to the domain of the printers, and so on. And it's mean that we can create one global policy for layer 3 networking devices. In addition, this model allows local ACLs to be provided on access switches, dynamically assigned within during the authorization of the network access control, which allows you apply security policies for communication on the same network, on the same VLAN. The policies typically on access switches are based on the second layer from this network or from this VLAN, and fourth layer and upper, this protocol, this port, and partly is there the third layer. This is only for communication to other network. This then allows us to ensure that, for example, that one PC cannot communicate via dangerous protocols with another PC on the same network. We can explain here on the picture. We have here PCs on the same network, on the same VLAN, and the dynamic ACL typically allow communication to the network of the printers, to the network of the servers without any restriction, because the policy for communication between the network, between different VLANs, is based on layer 3 networking device, which provide this policy. But on the same network, on the same VLAN, we can, for example, disable dangerous protocols, which is used typically, for example, for ransomware attacks. This is TCP protocol port 445, 139. This is 39. This is Samba protocol, or protocol for RDP 3389, and so on. Or we can allow only safe protocols, for example, DHCP, DNS, RRP, and so on. So this is for decision of the administrator who provide these security policies. But if we provide these local ACLs on access switches, it means that it is not possible that, for example, one PC, if it's infected, can infect another PC, even this PC is connected to the same VLAN, to the same network. Because, for example, we allow only safe protocols, through these protocols it's not possible to infect other devices, or we block the dangerous protocols, which will be explained later in practice. So you can see here on the picture very simple policies which is done by local ACLs. And if I do some of the benefits, we can see here. Typically, we can, using correct local dynamic assigned ACLs on the access switches, we can increase the network resilience up to 1 to 2 orders of magnitude. 10 times or 100 times the network will be safety for ransomware infection. This is very nice. The device typically does not see to other device within the same VLAN. And ADDNet addresses the risk of malware infection preventionally by enhancing network security policies. We explain it later on the live demo. On layer 3 networking device, we really simplify and clarify security policies, because in this case exists only one global policy, not, for example, 10 local policies corresponds to their locations, to their branch offices. So I think this is about my presentation, and now I start sharing another screen where we can you can see practice using of the ACLs. Now I'm connected to ADDNet demo. This ADDNet demo is one of our systems where typically exists 3 locations: location A, location Dublin, and location Bonn. And on these 3 locations, we provide communication about 400 devices. And now, at the first, I start about the DACL, because I think that you see these screens about ADDNet on previous presentations. So it is not necessary that I explain you what is ADDNet. I switch now to English. And now I open DACLs. At the first, we must define which switch type we have on the network, because each vendor provide different possibilities for DHCLs. For example, if we look on Cisco, on the detail, we can see that Cisco do not provide possibility to provide filtering on IP version 6. Cisco do not provide possibility to set more ports on one ACL line, and so on. So when we have preparing this is very simple. We can start to create the Acl templates. For example, I explain you how simple we provide DACL for blocking ransomware on Cisco. You can see that ADDNet use unified interface, and typically ADDNet offer you radius attributes which is necessary to set the ACL. You can see that on Cisco, this is the Cisco AV pair, and here this type, if we block or permit on deny, direction in, this is from the point of the switch is the connection direction in, but from the point of the device is the connection out. So in this case, we allow complete connection at the first to the server, to the address ranges where the server services are provided. You can see here that typically if we use the recommended model will be only this line, because this is typically the network where the servers services are provided, but mostly is the server services provided in user networks, typically, for example, on the first 92 addresses. So here we explain that it is not problem to set this. Here is all PCs networks where the and address blocks where the services is provided. So we allow communication to the networking to the networking services provided by the servers. After that, we block the communication which is used typically for ransomware infection. This is port TCP 445, TCP port 139, TCP port 3389. This is remote desktop, and these blocks typically NetBIOS. And after that, we allow all. In this case, when the device is is connected to the same access switch, when the device is authenticated by NAC, after that is authorized, and in authorization information we send to the switches dynamically this information, and in this case the one device cannot infect the second device by these protocols. And if I wish add, for example, new vector, for example, a pair that ransomware use, for example, another protocol, for example, use TCP protocol, port 1, this, I can very simple put here, put this line upper that will be on correspond position, and very simple save and back, a new policy is applied. You can see that it is very simple, and we can look now how you must provide this, for example, on Cisco ISE. On Cisco ISE, you cannot use this simplified interface, unified interface. You must write on Cisco ISE in this format. And you can see here that this is typically format which is typically must be done by administrator. It is not possible that will be done by only operator. And one important is that if you, for example, create here some mistake, for example, I type here not N but M, this is similar characters on the keyboard is between together, and on the screen seems the same. All switches works completely on the same mechanism. If in authorization information receive the first DACL, and at this time the switch set the policy to deny, the global policy to deny, if the switch receive, for example, on 8th line, wrong information, all ACLs which receive it before is forgotten. All ACLs which will be receive it after is not applied, but the policy stay denied. In this case, no one device can communicate because the policy is denied, global policy is denied, and no one ACL is applied. Cisco ISE provide functionality for syntax checking that if you mistype, Cisco tell you provide here mistyping, but only for Cisco. For example, if you on Cisco ISE start writing, for example, for HPA, it on ADDNet looks here. You can see that this is the same on the Cisco ISE, only is used another radius attribute, but on Cisco ISE you must write in this format. So what is nice on ADDNet, that putting this policy is very simple and can be provided by typically by operator. Now when we prepare this DACL, we put it into ACL, and for example, you can see here that user, for example, here ACL Nebit user is provided, but DACL for Cisco, DACL for HPA, and DACL for Huawei. And because ADDNet know, you can see here group of the switch. Here I have here switch group type for DACL. Here I provide the information Cisco. If I have, for example, another switches, I must provide another group of switches, for example, for HPA or for Huawei. In this case, ADDNet know exactly that this switch with typically, pardon, I'm sorry, that for example, this switch with this IP address is in a group for Cisco and should be applied to this switch, radius DACLs for Cisco. In this case, ADDNet automatically put correct DACL to corresponding switch. So it is not necessary that you tell on this switch must be this DACL and so on. Only by grouping the switches into groups and select correct type of the switches on this group and assigning the switch groups to the networks. You can see here, I assign that this group of switches is assigned to these networks. ADDNet automatically know which DACL should be sent to which device. And how? Very simple, because whenever we look on address planning, for example, for some networks, we can look that here we select that if, for example, you put some device to this network, select, I explain you how we can do this. You can, for example, select, okay, some new device will be put it to this network. Automatically to this device is applied ACL, name it user. Or the same, I can, for example, tell on this network, I can connect only on work hours. So this is really very simple, and I explain you now how I can put the device to the network and how it is simple. I use now that I look for only new devices. I select here guest only, and I have here new devices. And if I wish, for example, this device put to the ADDNet, I select here fix. Now I select here that it will be, for example, for in PC in main office R. I select here a profile only for PCs, because if I do not select and I select here free from networks, you can see here long list. But if I select here only PCs for Office A, I select the free from networks, ADNet offer me only the networks which is usually typically only for PCs. Okay, I select here station, I select IP address, ADNet offer me free IP addresses. I select here which authentication will be used by MAC address or by, for example, full 801.x. And for example, here I have here information which is read automatically from ADNet, and for example, Piotr Polski. And in this case, on this device identified on with this MAC address is allow that will be authenticated only Piotr Polski, or this one, and so on. Or I can tell on this device can be authenticate any user with valid credentials. The same is if the device should be able to connect in other location. In this case, the device is not able to connect on other location, or the device is able to connect on another location, and so on. So this is very simple how I can put the device to the network, because here I apply which DNS will be automatically created, DNS record. ADNet automatically create primary and reverse DNS record. Here is some IP descriptions. Here is some device description. For example, in PC1A and so on, and very simple insert and back, and all is done. So you can see here that putting the device to the network is very simple. So it is about the ACLs. Anya, now I start speaking about another, because when we use MAC authentication, many customers use this method because this is very simple. It is not necessary to set supplicants. There is no problem with supplicants and so on. So you can use that the device is authenticated by the MAC, and this is really very simple. But many administrators told us, but set on the device any MAC address is very simple. This is not security. Of course, they have true, but at the first, if the customer have no network access control, setting the MAC authentication is much better, because it's possible that will be provide the mikrosegmentation. This is the first. And the second, ADDNet offer 3 independent methods to detect MAC spoofing. This detection is provided by Alert Center, and I explain you these 3 methods. So now I switch to the Alert Center, and here we can see in modules, and one method is the DHCP fingerprint. The DHCP fingerprint typically used that when the device send the DHCP message to the network, for example, discover or request or inform or decline and so on, this DHCP message has own fingerprint, and we can check if the device use the same DHCP fingerprint or not. And I explain you that this fingerprint is very powerful because when we look, for example, for some DHCP events, I filter here. You can see this is the incoming DHCP fingerprints. You can see here that typically the DHCP option request list is the long list, and we check not only that, for example, this list is the same, that there are the same numbers of requested DHCP options, but the order is same. And it is not so simple to provide the DHCP fingerprint in the same as other devices. This is the first method. So if the DHCP fingerprint is changed, we know it, and we send information through alert center, for example, to CM, to some trouble ticket, or via SMS. It is possible to provide any method of sending of information via alert center to upper systems. So the second module, which is duplicate MAC. So it means that in the same time appears the same MAC address on different ports on different switches. This method is possible to use, for example, if in the same time appears the same network in Dublin or in Bonn, ADDNet detect this. So it means that appears the same MAC address on 2 or more different locations. This is the second method. And the third method is static device moving. Many times the devices is typically table PCs, which is typically on the same location each time. And you very simple set in ADDNet this device, you only do provide this by the checkbox, cannot move. And if the device appears on another switch or on another location, ADDNet send this information. I explain you now, for example, how looks, for example, this alerting. For example, I try here that I choose here critical for past 7 days, apply filter, and now we can see duplicate MAC. We can look for the detail, and you can see that from this time to this time appear this MAC address on this port of this switch and of this port of this switch. And you can see that ADDNet sent, of course, information which is similar as this. This is the similar as this information. Yes, this is the same. So when, for example, this information appear in some security operations center, the operator click from this automatic URL will be redirected to this screen, and here apply very simple complete info about this. Now you can see, yes, this is the valid DHCP client, okay, but now he can see that it is a really problem because typically this device is connected in Office Bonn in 2nd floor in manager room, but in the same time is connected in Office Bonn in 1st floor in support room. Yes, this is really that somebody which is connected now in support room try to set the same MAC address as has the manager. He can, we can after that provide very simple drill down by IP address, info about IP address. And now we can see that this is this notebook, and the operator can very simple change the network. I select here quarantine, and I select here some IP address from quarantine network. And if I provide update and back and commit this device is immediately moved to the quarantine VLAN. And typically, when the device asks for request for lease time prolong, ADDNet send reject, provide full discover, and the device receive the new IP address this. And in this case, the operator, very simple, write a ticket. The device, this with IP address and so on, appears that somebody try to provide settings of the same MAC address and provide that looks as this device. I completely move the device of the attacker and the device of the director to the quarantine, and I said that this device should sure receive this IP address. So the devices or device, one or more devices, both are isolated in quarantine network, and the incident is solved. So this is very big difference between many security operation centers when, for example, some system detects that something is wrong. After that, the operator, for example, at 1 AM, call to somebody, hey guy, you have a big problem on your network. This device provides you some very bad. Do with this something, provide response. I'm not able to provide a response. Do this. But if a customer has ADDNet inside, if the customer can grant access to the ADDNet, and the operator of the security operations center can provide full response, which typically isolate the device in quarantine network or disconnect the device. This is the same. You can see here, I can here disable, this is the same. So you can see here that this is very nice. And one of that, for example, the operator can send information, for example, to some security staff in the network where, oh, sorry, I better, I'll check, return back. Maybe this is info. Where and what is simple can send information where typically the attacker is located to the security staff, because ADDNet provide cable book visualization and can send, for example, via some smartphone to the security staff, and the attacker is here. So this is really very nice, because now you know that start the globalization, many companies groups together. So typically the companies has thousands of devices, has many locations together, and if you have the cable book visualization, it's great that you know exactly where the device is connected. So I think now this is all from my live presentation, and now it's time for the questions. So please.
Thank you, Petrze, for your presentation. Just let me to check if we have some questions. Yes, and this is a question to you.
Yes.
How often do you find that the companies have advanced network policies with micro-segmentation?
This is typically these policies with micro-segmentation we met only very minimal, because the problem on many companies is that if you wish to have micro-segmentation implied, which is not statically set, which is set dynamically, because the security is not statically, the security grows rapidly, and you must follow this security. So the security policies must be applied dynamically. So for this, you need fully implemented network access control, because dynamically assigned security policies can be only done if you have, say, network access control. And you told before that many companies have the problem that the network access control is not implemented fully, or typically partially, or not. They start implementing of network access control and not fully implemented. And why? The answer is very simple. Not of all devices support supplicants, so must be used MAC authentication. You can see here that on ADDNet, the MAC authentication is very simple to set. But for example, on Cisco ISE, you must select this MAC address is allowed, and you put new device, another MAC address. But in Cisco ISE exists only set of MAC addresses without any chance to control if the MAC address is really on the network correctly, if the MAC address exists on the network at this time or not, that the device is removed, and so on. So there is very hard to imply, for example, MAC authentication on Cisco ISE, because Cisco ISE, for example, provide very nice interface for integration with Microsoft Active Directory, but not of all devices are in Microsoft Active Directory. So ADDNet fulfill all, because we provide very nice integration with Microsoft Active Directory, similarly as Cisco ISE, but we provide very nice interface for implement MAC authentication, and this can be done mutually. So some devices can be authenticated with MAC address, some devices by, for example, Microsoft Active Directory. So I think that the problem with microsegmentation, implementation microsegmentation companies is that not of all companies has full network access control provided up to end. Okay.
Thank you. Yeah. One more question, also to you. What is your opinion about my microsegmentation? Which one is more appropriate? Central microsegmentation on firewall level, or distributed on the switch level?
I think that the best model is when both method is used, which I explain on my presentation. Because if we provide only centralized microsegmentation, in this case, we must have got the switches which support port isolation. It means that, for example, even the device is connected to the same network. If we set the port isolation, typically the communication is sent to the central networking device. There is applied the policy and sent is back. In this case, at the first, we need really expensive access switches which support port isolation. And the second, we need very huge layer 3 networking device, because all communication, completely all communication, is done through this device, communication between two devices, and so on. So from my point, it is the best when for policies across the networks, across the security domains based on the VLANs, is done on layer 3 networking devices, which is typically one device, typically for locality, for location, and the dynamic ACLs, which is sent by network access control authorization process, is done on the access switches. This is the best model, and you can see, for example, ADDNet offer very nice interface how these policies, these microsegmentation policies, can be applied. So this is my opinion, but another can have another opinion. Yes,
that's true. Okay, let me check if we have more questions. No, I cannot see more questions. So in this case, Petrze, thank you very much for answering the questions and also for your very detailed and practical presentation. Ja oczywiście bardzo serdecznie chciałabym również podziękować Państwu za nasze spotkanie, za uczestnictwo oraz za możliwość właśnie spotkania się z Państwem po raz ostatni przed krótką przerwą wakacyjną. Do zobaczenia już na początku prawdopodobnie września. Z naszej strony to wszystko. Proszę, łapcie słońce. Do zobaczenia. Dziękujemy bardzo za spotkanie.
Bye bye.